Deep Learning in Healthcare. Part of course CS598 Spring 2023 Project Work. We, Shayan Chakrabarty and Shubhra Das of Team 144, selected a paper, SAND, Simply Attend and Diagnose, and tried to replicate the experiment and reported our findings. Our paper proposes a method for analyzing clinical time series data using attention model, paper ID 18. Here is the architecture of SAND model. The input is fed into a multi-head attention module which employs temporal positional encoding to enable parallel processing of self-attention. When the time series data's vector representation exits the attention module, it passes through a dense interpolation module to create a concise, temporally structured single vector representation. Finally, the data goes to a linear layer and softmax to generate human readable probability scores considered as predictions. We have replicated SAND to 3 mimicry benchmark tasks from the paper. In hospital mortality, we have received AUC-ROC value 0.53, accuracy 0.81, underperforming in compared to what paper claimed. In hospital stay, values are bucketed into 10 categories for multi-class classification. Our Cohen-Kappa matrix value 0.009 from confusion matrix is lower than what paper claimed. We have calculated mean square error and mean absolute percentage error value also. We have utilized benchmark phenotype classification from another paper in this model. We have included patients with less than 100 lab tests during their hospital visits, median value around 30, and have achieved accuracy of 0.68. Here is our analysis of the result. In hospital mortality, our results deviate from the paper due to unclear masking of input attention sequences. In hospital stay, we have obtained 0.0098 Cohen-Kappa value, indicating slight agreement between true and predicted levels, while the paper reported fair agreement. Unclear MSE and MAPE calculations in classification tasks may explain this discrepancy. In phenotype, benchmark phenotype classification guidance was unavailable, requiring us to independently develop and evaluate the training section without substantial existence of code assistance. We have also done a couple of ablations other than 3 mimicry benchmark tasks. Executed our code without dense interpolation layer, achieving ROC of 0.485, nearly at par with the original model. Also executed our code with RNN only, removing attention, and achieved ROC AUC of 0.895. This improved result due to proper usage of masking and bidirectional RNN. We have observed best combinations of stacking layers, dense interpolation factor, and other hyperparameters. We have shared the completed code and paper links. Please feel free to drop the emails for any questions and clarifications. Thank you for watching our project work video.